I welcome you all for this lecture series on 4G and 5G communication networks. In this lecture, that is lecture number 8, we will briefly look into the comparisons of 4G and 5G networks. We are going to discuss the various features, what is the comparison between 4G and 5G that we'll be briefly discussing in this lecture. First, the feature is the speed. The maximum speed of 4G network, if you are looking into the 4G, that we can call it as a long-term evolution. The maximum speed of 4G network typically reaches up to 100 megabits per second for downloads, and this is downloads. This 1 gigabits per second for uploads under ideal conditions. This level of performance supports high definition video streaming and fast web browsing, but can be limiting for more data intensive applications. So if you are looking into this 5G network significantly enhance speed capabilities, offering download speeds up to 10 gigabits per second and upload speed up to 3 gigabits per second. This dramatic increase in speed supports advanced applications such as ultra high definition video streaming, large data transfer, and real time applications like virtual reality. The second feature is the latency. The latency in 4G network generally ranges between 30 to 50 milliseconds. This delay is sufficient for more current applications, but it can impact real-time communication and gaming where low latency is crucial. If you are taking the 5G network, one of the key advantages of 5G is its reduced latency, which ranges from 1 to 10 milliseconds. This minimal delay enhances user experience and applications requiring near instantaneous response times, such as autonomous vehicles and real-time remote control systems. And this is the main advantages of using this 5G. The next feature is the 4G, that is bandwidth. The 4G network uses the maximum bandwidth of 20 megahertz. MHz represents the megahertz bandwidth per channel, which can limit data throughput and overall network capacity. This bandwidth is adequate for current mobile data needs but become a bottleneck as demand for data increases. So if you are taking into this 5G technology utilizes a much broader range of bandwidth from, see here, 100 megahertz to 1 gigahertz per channel. This substantial increase allows 5G networks to handle vastly larger volumes of data and support more simultaneous connections, improving overall network efficiency. This is the biggest advantages of using 5G. The next feature is the frequency bands. The 4G networks primarily operates within frequency below, that is 3 gigahertz. These lower frequency provide decent coverage and the penetration through buildings, but have limited capacity compared to higher frequencies. And if you are taking the 5G network, use both below 3 gigahertz and in the millimeter wave spectrum up to 100 gigahertz, that we can call it as wave. While higher frequencies can carry more data, they require more base stations for coverage and have reduced penetration through physical obstacles. This is also one of the biggest advantages of using 5G as compared to this 4G, that is LGA. The next feature is the network capacities here. The capacity of 4G network is constantly by their bandwidth and frequency limitations. This is one of the limitations of 4G. As a result, network congestion can occur in densely populated areas or during peak usage times affecting performances. This is the main drawback of using this 4G. And if you are taking the 5G network offers significantly higher capacity due to their advanced technology and broad bandwidth, that is broader bandwidth. This increased in capacity supports a large number of connected devices and more data heavy applications without compromising the performances. This is also another advantages of using 5G. The next feature is the device density. 4G networks can support up to, let's see here, support up to 2000 devices per square meter, and the density is generally sufficient for urban environment but may struggle in highly congested areas or during peak usage times. Next, the 5G. The 5G networks are designed to handle up to 1 million devices, 1 million devices per square meter. But in this 4G, only 2000, not 20,000, 2000 devices per square meter. One more time, I'll tell you 5G network is designed to handle up to 1 million devices per square meter. This massive increase in device density is crucial for supporting the growing number of IoT devices and connected applications in smart cities and industrial environment. So this is also another advantages of using 5G. The next feature is the coverage. As far as the coverage is considered, coverage in 4G network is relatively broad due to the low frequencies used, which provides good penetration and range. However, fewer cells are needed, which can lead the coverage gaps in densely populated or remote areas. Whereas 5G coverage requires denser networks of cells, especially at higher frequencies, to ensure reliable performances. While this allows for more robust and high-speed connectivity, it also means more infrastructure is needed to achieve comprehensive coverage. So the next feature is the use cases. The primary use case for 4G include mobile internet access, video streaming, social media, and general browsing. It supports most current applications effectively but has limitations for emerging technologies. And if you are taking the 5G, 5G expands the use cases to include enhanced mobile broadband, massive IoT devices, massive IoT deployments, autonomous vehicle, and augmented or virtual reality that we can call it as AR VR. Its high speed, low latency, and increased capacity enables innovative applications and technologies that require robust network support. So the next feature is the network architecture. First, if you are taking the 4G, 4G networks are largely based on cellular architectures with some integration of small cells. This design supports broad coverage, but what is the drawback is maybe less efficient in handling high density traffic compared to new technologies. And so we can call it as a centralized architecture. This 5G introduces more complex network architecture that includes a dense network of small cells alongside traditional macro cells. This architecture supports improved performance and capacity, especially in high demand areas and for advanced application. So that we can call it as this decentralized architecture with the edge computing. So the next feature is the energy efficiency. The 10th feature is energy efficiency. And the 4G network generally consumes more power relative to their performance capabilities, leading to higher operational cost and environment impact. But this 5G technology is designed with a greater energy efficiency in mind. Advances such as improved network design and more efficient hardware contribute to reduced power consumption while delivering higher performance, making it more sustainable in the long run. So one more time I'll tell you, this is hence we can call it as this 4G is moderate energy consumption and the 5G is improved energy efficiency, especially for high density areas. And so the final feature is the deployment of this 4G. The deployment of 4G network is relatively straightforward compared to network technologies, that is newer technologies. One more time I'll tell you, the deployment of 4G network is relatively straightforward compared to newer technologies with established infrastructure and fewer technical challenges. So it is this 4G is well established globally. The 5G, deploying 5G networks is more complex. Why it is more complex? Due to the need of additional infrastructures, including a greater number of base stations and support for high frequency bands. This completely results in higher initial deployment cost, but is necessary for achieving the enhanced performance and capabilities. So, the still expanding with ongoing rollout. So, these are all the comparisons of 4G and 5G. So, one more time, I'll tell you what are all the features we have seen. The first feature the first comparison is the speed, latency, bandwidth, frequency bands, network capacity, device density, coverage, use cases, network architecture of 4G and 5G, energy efficiency of 4G and 5G in deployment. Hope everyone understood this lecture about the comparisons of 4G and 5G. The remaining things we'll discuss in the future lecture. Thank you.